All right, today's problem is binary tree maximum path sum. So they give us a binary tree, and you can see here we have a path of 2, 1, 3. That gives us a sum of 6. And here our maximum sum is this path, 15 plus 20 plus 7. So let's solve the simpler problem first, where we don't have to worry about if it's in the subtree. Let's just see if we can solve it where it's at the root. So you can see here we have an example, and we want to find the maximum path sum where that takes an account of 20. So here our max sum will include 20. And then we want to find out what's the maximum subpath on the right side, or none if we decide not to take it at all. So we'll initialize it to 0, and also for the left side. So you can see on the left side, we can recursively ask 7, what is your optimal subpath? And then 7 does a comparison between 2 and 3, and we find that 3 is the maximum subpath. So we return this path up to our caller, which has a value of 10. And 10 is better than not using it at all. So we replace this initialize 0 with 10. Now on the other side, now we can ask 15 the same question. So 15 will, well, let's see. So what we'll have is, let's break this down. We have 15 with -4 and -5. So since it's recursive, 15 will also ask -4 and -5. So you can see something like this for 15, where we choose 15, and we initialize these two to zeros. Again, 0 meaning that we don't take that path. So here, we would have returned -4. And since -4 is not bigger than 0, we just decide we're not going to use this path. And then again, here with -5, we're not going to use it, which means that, well, 1, our maximum sum here is 15, but our maximum subpath is also just this 15. So that means we return here this green value back up. And that's different from this 7. So you can see here with 7, the sum and the subpath are actually two different things, right? So here we have a max sum of 2 plus 7 plus 3. Let me move this down. But our max subpath is actually just this one, 7 and 3. 7 plus 3. So this is our maximum subpath. So here I'm defining subpath to be you can only either choose the left side or the right side. That way the parent can find a path that is straight from the parent like this. Because if we return something like this is no longer a subpath, but this is a tree, so this wouldn't work. Okay, so let's try implementing this. So here, what we'll do is we want to have some sort of a way to find out the max subpath sum. So we'll have it be a recursive function, and then again we initialize the left as 0, meaning we're not going to take it, and our right as 0. And if we have a left value, then what we can do is we can update left with either itself, so at this point it just means that we don't take it, or we will recursively ask the left side to tell us the maximum subpath. And we'll do the same thing for the right side. Okay, so with that, now we know our best left subpath and our best right subpath. That means to return to the parent, all we have to do is include our own value, because max subpath sum always includes the node's value. And then we'll plus it with the choice between the better of two, either left or the right. Okay, so now what we have here is a recursive function that tells the parent what is the maximum subpath to take. But at the same time, we also have enough information to calculate our own node's local path sum, which is different from a subpath. So here, our own path sum is going to be equal to node.val plus left plus right. So that means now we can do let's see, if we go back to here, this path sum means that we're doing this we're combining these two together now. Okay, so now we need a way to tell the outside world if we have seen the maximum, because that's what we're really trying to solve in the beginning. So what you can do at this point is you can either create a class variable, like total max, something like that. Or if you want to keep this, not use the class and want to keep it all within this function, you can pass in an int array here of our max. And then this max will just be a single array with a single element where the first element is just the max that we've seen. Okay, so here what we can do is if we've found a path sum that's greater than anything that we found so far, we'll just overwrite it. And then how we call this is let's have some sort of a max first. And the maximum we know at this point is just that, it's probably just a root dot val. And since we're guaranteed that the tree will not be empty, this call won't fail on us. And then we'll invoke this for our root at our max. And you notice here we don't really care about the return value, versus here we care about it because we were trying to find the maximum subpath. But we don't want to find the maximum subpath of the root. We just want to find out when you go through this and you have to go through each node, just to keep tallying up which is the maximum subpath you've seen so far. That way at the end, we can just return the max of this value. So this will be max 0. Whew, okay, I think that is it. Let me make sure we want to pass this down in our recursion. Cool. So you can see in this, we basically go through the whole tree. We visit every single node that's not null. So it's going to have a runtime of O of n as well. All right. Well, that's the end of today, and I'll see you on the next one.